Okay, so we are going to look at gravity problem D. And gravity problem D reads, if you drop a stone into a well and it takes 2 seconds to hear the splash, now assume we hear the splash as soon as it hits the water, how high is the well? All right, so let's look at our object of interest. So what object are we thinking about the motion for? Well, that stone being dropped into the well. Now, what defines the beginning of our motion that we care about, and what defines the end of the motion that we care about? Well, the beginning of the motion is when we drop that stone. And the motion ends when we hear the splash. Now, we're going to make the assumption, as instructed, that that splash occurs at the point of water contact. So, when it hits the bottom of the well. We want to ask ourselves a little bit about the problem. Am I in one dimension? Yep, I'm just letting that stone fall. And am I in free fall? Yeah, you bet. So we're in free fall and one dimension. Okay, so now we have to define the world. So here's my well there on the ground, and here's where the water is. And I'm going to define the origin at the point where the stone is dropped from the bottom of the well, at the bottom at least of the ground to the well. All right, so we want to know our known values in our general list. So I have initial and final position, initial and final velocity, acceleration, and time. Initial position. When do we start carrying? We start carrying when the stone is dropped. I've defined that as the origin. Final position, don't know, not given in the problem. Where that water is relative to the top, we don't know. Initial velocity, the stone is dropped. How fast is it moving when we let go of it? Right at the beginning, it's moving at 0 meters per second. Final, we don't know. Acceleration, we're in free fall, and free fall is defined for us as a constant negative, regardless of direction, of motion, meters per second squared. It's only gravity acting on the object, causing it to fall and speed up as it goes. Time, we don't know. We do know. Time is 2 seconds. It's given in the problem. So we hear that splash 2 seconds later. All right, what are we interested? Pause video. Don't forget to use that technique. Test what you're interested in, what answers the question, and then check it with the rest of the video. Well, we're interested in how high the well is, the position of the well. And x final is going to give us that value. So our equation that gives us position information is x final equals x initial plus v initial times t. I am writing these equations wrong, too fast. Let's start over. X final equals x initial plus v initial times time plus 1/2 acceleration times time squared. All right, that's our base equation. Now let's look and see what we got. X final, we don't know. In fact, that's what we care about. We leave that as its variable. X initial is 0. V initial is 0 times our time of 2 seconds plus 1/2 negative 9.8 times our time of 2 seconds squared. All right, solving for x final, we get negative 19.6 meters. Well, we always want to check, does that make sense? Well, we may not be able to intuit sort of the direction, but does this negative make sense? Well, the bottom of the well is below the origin. Now, that means that our position at the end of the motion should in fact be negative. And so the well is 19.6 meters deep. That negative coming out of our answer is truly position, and we can recognize that it's appropriate. Nice job.